Alright, so in this video, we were going to do the insect example from Unreal 5, which if you don't know what that is, it's essentially, there's a scene in that trailer where the lead character, she enters a temple and there's a wall full of insects. And as she sort of moves the light around, so wherever the light hits, the insects sort of scatter. So this is the result, that we would essentially get from that. Okay, so this is a fairly rough version of it. But what I decided was that instead of just doing like one example, let's do a few variety of things, which is essentially what we're doing is, this is not particle based, this is essentially rigid bodies. Okay, so the nice thing about Houdini is that the same particle forces also work for rigid bodies, because it sort of treats rigid bodies as, or treats the center of the rigid body as a particle. So you can apply the same forces. So I just decided to make a couple more examples of using particle forces on rigid bodies. So this is one of them. Okay, so we'll just take a look at how to use that with, with rigid bodies. And there's another one which is, which is this. Hold on, let me just zoom out a bit. Alright, so to get started, I'll start off with the simplest example, which is, let's say if I just take a box and I'll do a point from volume, and I can just, you can say add scale attribute, so it will generate like a p scale value, but we'll keep that to 1. And how many points do I have? About 1300, which is fine. Okay, then I can just take a simple sphere, and let's also do one thing. I'm going to take the point configuration to like tetrahedral, and then just do a copy to points. And just make the size smaller till they are not intersecting. Okay, I think this is good enough. Okay, then you can just take an RBD solver, like that's pretty much it. You don't need to do anything else. Like in this case, we don't really want it to do anything fancy. Like I don't want it to collide with anything or anything like that. So what we can do is, we can make quite a few changes to make this faster. Like firstly, the sub steps are usually kept to 10, but in our case, I think we can bring it down to 3. Like that should be good enough. And the collisions by default are calculated on like the full geometry, but you can change that to sphere. Okay, because we just have spheres, so we don't have to do anything. Plus we have no other external collision objects either. So it will just go faster. And then lastly, come to forces and make the gravity 0. Okay, so that's pretty much it. Now let's come in to the RBD solver, and it gives you a place to wire the particle forces. So let's say if I just do a pop attract, okay, so which will be in the center, which is good. So I'll just drop that in and I'll increase the force. So what we should get if I press play is, see, they all just get attracted to, the center. Now along with this, let's say if I give it a little bit of like noise, so I'll take a pop force and I'll just give it some amplitude, and if I press play, see, so you'll get something fancy like that. Now along with this, let's say if we come up here to the points from volume, and I can add a noise to the p scale. Okay, so what I can do is I can just take attribute noise, set it to 1D and multiplicative, and we'll just call it p scale. And I'll remap it to say around 0.5 and 1. So what you'll get is something like this. Except let's get the element size smaller. Yeah. And we'll also get the roughness lower. Okay. So you should get like a little more variation on the whole thing. So I'll just do Shift W and press play, and see, there you go. So now you can get something a little more fancy. And then I can just add, maybe I can just add a drag to this. So I can take a pop drag. So you can just, control it a little bit. Yeah, there you go. See. So you can create stuff like this very easily, because you're just using the particle forces, so it doesn't matter. Now, let's say if at this level I was to give it some color or something, like let's say if I take a pop color and I apply this, and I'll do like this doesn't have age, so we'll just do speed. Okay, and if you press play, then see, you'll get this. Okay. And we can just, like, I'll set it to two-tone. Yeah, I think two-tone is good. Okay, so this is nice, but when we come up to geometry level, there is no color. So how do you bring that value in here is fairly simple. If you come into the rigid body solver and you come to the advanced menu, okay, and you'll find something called output. So in the output, it has the option to transfer whatever attributes you have inside the RBD solver up to like SOP level. So just click there and you find color and just say transfer to geometry, and that's it. So it'll just transfer all of that over to geometry. So it's a pretty simple way to work. And then we can make changes to this. So let's say instead of doing a points from volume, let's say if I just take a sphere and I can set the sphere to scatter. And even in the scatter, you have the option to turn on, P scale. So let's just see what we get. Okay, but slightly bigger. Okay, and then let's say I want it to sort of collide with something in the center. Like this will be okay. They'll all just jump right into the middle like that. But let's say what we want is maybe there's like let's try something. Let's take a test rubber toy or something. Or let's take the pig head. Yeah. Okay, let's take the pig head and I'll just, move it up and make it tiny. Okay, let's take this. And now we'll have to change the RBD bullet solver. The collision that we had set to sphere, that will have to be changed because then it will calculate this as a sphere as well. So make sure that you keep it to convex hull. And then take this and connect it to the collision geometry, which is the fourth input. And now if you press play, and I'll do a null and bring it out. So what we should get is, see, you'll get something like that. Okay, I don't think it's going very precise. Yeah, okay, hold on a second. Set this to concave. Yeah, so there you go. So this is something that you can get with this. Now another example we can take a look at is what if you want to fill a piece of geometry. Okay, so what I can do is, let's take a font, because I'll just take a piece of text or something, and let's keep this to, let's try U. U should be simple enough. And let's make this, firstly I'll make it thicker. So we'll go to Arial black. Yeah, okay. And then just make it big enough. Okay, now take a poly extrude. I'll give it some thickness and do output back. Okay, and then let's give it a peak and make it thicker. This will be my collision object. Okay, so we'll get this. Like if you look at it, see, there's the internal piece and this is the external. And then let's give it another poly extrude to turn it into like a shell. Okay, so I can just take this and make it bigger and do output back. This will be my collision object. Okay, now with this guy, what I want to do is, let me just take a clip. And I want to like clip below plane because I don't want to fill up the whole thing. So let's say I want to fill up till here. And then give it a poly cap. Okay, and then take a points from volume. So take a points from volume. So it will fill it up. Again, I'll set it to tetrahedral. Okay, and then let's do one thing. Let's copy the same thing here. So we'll just take this and the noise as well. So I'll do Control C, Control V. Yeah, so firstly, like in the points from volume, turn on the add scale attribute and keep it to 1, or maybe smaller still. Yeah, I think this is good. Just make sure that the outer shell is not intersecting with it. Yeah, I think this is good. Okay. Okay, so we've done this much. So let's do a bullet solver and see if it's working. So we'll pick up the bullet solver, and this comes in here and this comes into the collision geometry. And let's make a few changes. So this will be concave. Let's get the substeps down to 3. Let's put a null so that we don't see it. Okay, let's play this and see what we get. See, there you go. So it fills up, okay, which is good. Maybe let's do one thing. Let's take the clip slightly higher. Yeah, let's try to make the size slightly bigger. Yeah, okay. Because I don't want to, because if they're too small, they'll just sort of, they won't fill up in general. But yeah, this is good. Maybe 0.6 is fine. Yeah, okay. I think this is good. Okay, now what I can do is, let's say I wanted to sort of slosh around every few seconds or something like that. So what I can do is, let's keep this here. I'm going to take a box and let's keep this long and tall like that. Okay. And then let's give this a points from volume. And what I want to do is I want to give it some velocity. So I'll take a point velocity. So literally everything that we were doing with particles is applicable here. Okay, so I can take a point velocity and just give it a y velocity of 5. Then let's take a transform and I want to see this. And what I want to do is move it in the x, but using like a cos function. Okay, so we'll take a cos of $f, let's try into 5, into, let's try 2. So it's going to move from +2 to -2 and it'll do it, relatively quickly. Okay, so that's what we have. Now, why did I use cos and not sine? Because sine starts from 0. So you'll get it in the middle. Cos will start from the edge. Okay, and then I want to convert this into a volume. So just take a rasterize. So we can take a volume rasterize attribute and just rasterize the V. Yeah, and change this to point. Okay, and then we'll do a null. I can just say out V. Okay, so let's see if this is working or not. So we'll come in here and I'm going to take an advect. So pop advect by volume and I'm going to pick up the out V and the field name is V, and don't treat it as wind and just increase the velocity scale. So if you've done everything right, see, there you go. Okay, that's too much, and I think the collision has a bit of a problem. So let's do a couple of things here. Yeah, let's make it slightly smaller and we'll lower the velocity. We'll also have to increase the substeps. I don't want to do that. So I'm just going to try and make sure it doesn't jump up so much. Okay, so I'm going to take the clip as well and lower it. Yeah. Yeah, there you go. Alright, another thing we can try is we can try animating the collision geometry. Okay, so what I can do is I can come in here and let's take a transform. And what we'll do is, let's say we come to around 24, I'll do the Z axis rotation. So alt click, Let's come to 72 and I'll flip it, so 180. And then let's come to around 144, alt click, and then 216, and let's go back to 359. Now, one of the problems that's going to happen here is this geometry is not very good, so collisions could cause an issue. So what we can do is, after the peak, I can take a remesh. So I can put in a remesh here and just like lower the target size so we get a little more detail, and then we can also give it a smooth, okay, just to sort of round it off, and this should give us better, collision geometry. Now, another thing you want to do is, if you have very fast moving geometry, then you will have to increase the substeps, because at lower substeps the geometry might just sort of escape from the collision object. Okay, but let's just check and see what we get. Okay, at substeps of 3. Now, the final change you want to make is the initial object type needs to be kept to create deforming static object, because otherwise it won't take the transform into account. So let's just press play and see what we get. Like, if the collision holds up, great. Otherwise, we might have to increase the sub. See, there you go. You can see some of the sphere starting to escape the whole thing. Plus, it's causing some issues there. So what I can do is, let's say I'll take it up to around 12 substeps. It will slow down, but when you have like complex movements like these, then you will have to increase substeps. See, now you don't have any escaping spheres. They still might, so you'll have to probably then go up to something like 20 substeps. And then if the geometry is really fast moving, then you'll have to have, I don't know, like 40, 50 substeps for it to be really nice. Yeah, we still got one guy escaping. So yeah, so maybe about 15 should be good enough. So yeah, so first of all, make sure that the collision geometry is nice and triangulated. Okay, so it became a J by the end of it, or something like that. Yeah, so you can use, basic particle forces and, stuff like that to create some interesting results. Okay, now let's take a look at our final example, which is this, the insects. So what I'll do is, I'll create it in the same file. Okay, so I'll just take a grid and I want to create a simple wall. Okay, I think it's caused an issue. Yeah, okay. Okay, I'll just make a new file. So let's come into geometry here and I'll create a grid. And let's bring this down to 2 and 2. And what I'll do is, I'm going to take the edge and we'll do a poly extrude. I'll turn on transform extruded front and just move it up like that. Okay, the next thing is, I want to extract like a small piece from the middle. So what we'll do is, we'll just take an edge loop and I'll just drop it in the middle. I'll set it to percentage so I can just move it around. Okay, and then we need about 4 of them. So 1, 2, and 3 and 4. So our insects will be in this area. Okay, so then I can take this and press 4, select those two, delete and non-selected. So this is where I want my spheres. Okay, now let's do something. Let's take a scatter and I'll just scatter some points on this. And let's take a sphere and we will copy this. So do copy to points. Okay, and then just make the sphere really tiny. Okay, this is good. You can try to increase, like you can give it the P scale so they won't intersect as much. Yeah, I think this is okay. Okay, so the first thing we want to do is let's animate, what we want is the torchlight to move across the wall, So let's first animate that. So what I'll do is I'm just going to come in here, like let's keep this, and then I'll take a null. I'll come up to object level and we'll take a null. Okay, and let's animate this. So we'll start off from, let's say, yeah, right there. And like this is the part where our insects are going to be. So we'll start here. And then let's do alt click and we'll come to 24. I'll just come to the edge and stop there. And let it be there for a little bit of time. And then it will move, inwards, and then let's go down. And then we'll come here. And again, we'll just, let's say we'll hold there for a second and then come there and go up and then move out. So if you press play, so we have this. Yeah, okay, it's holding there for too long. So let's do one thing. Yeah, let's bring that in. So this is good. So let's do one thing. Let's just get this into our geometry. So I'm going to take an object merge and say into this object, and we're going to come into the null and pick up the point. So it'll just pick up like the center point of the null. See, so that one. Yeah, like if I turn it on, see, so we can see like it has that one point and that is animated. Now what we want is we're going to use something called as a metaball force, which we haven't used so far. It basically creates like a radial force, but based on a metaball. So we'll take a metaball and do a copy to points. So it'll copy onto this and it'll move across. Okay. And then in order for it to work, let's just make it slightly bigger. And in order for it to work, it needs something called as a force. So you'll get a node called force. And this allows you to generate like a radial force and also a directional force. So I don't need a directional force. I'll just turn on radial. Okay, so this is fine. Now and then we'll take a null here. And I'll just do out metaball. So this is fine. So now let's come back here. And we'll set up our RBD solver. So what we're going to do is we don't need any gravity. So firstly come into forces, get rid of gravity. We'll take the substeps down to 4. I'll set the collisions to sphere because there is going to be spheres, nothing else. And the first thing we want is I want to attach it to the wall. Okay, so we're going to use like a min-pos function on our rigid body object. So what we'll do is I'll do a null here to this guy and I'll do out wall. So the first thing is jump in here into the RBD solver, take a wrangle, so a pop wrangle, we'll call it min-pos. Okay, and the input will be first context, the input will be SOP. And we want out wall. And then let's also just pick up the metaball force. We won't attach it right now, but that's also SOP and we'll pick up the out metaball. Okay. But we'll take the min-pos and then we'll do at P, capital P is equal to min-pos and 0 comma at P. Okay, and then to check if it's working or not, we'll just give it a force. So we'll take a pop force and give it a little bit of amplitude, lower the pulse length, and if we press play, see, so they'll stick to, see, there you go, they're sticking to the wall. So this is perfect. Okay, now let's drop in the metaball force and take the force scale to -2. Because by default, if it's positive, it will pull everything into, see, it will do that. So we don't want that. Okay, we want them to push away, and also just lower the amplitude a bit. Okay, so just make it minus, let's try 1.5 and then we'll adjust. So if you press play, see, that's what you'll get. So yeah, so now also take a drag so that we can, slow it down a bit. Okay, now the particles which are not moving on the ground, the reason for that could be that within the RBD solver, there's an option for sleeping. So if you come to the advanced tab and bullet solver, there's something called sleeping time. Okay, so make that 0. So it'll never sleep. So hopefully that should solve that problem. See, now they're moving. Yeah, there you go. So if ever you do an RBD simulation at SOP level and it suddenly stops to move, yeah, it's primarily because there's like a sleep time inside. Let's try something else. Let's take a pop interact and we'll give it a peak force of minus 0.5. What I want is, let's just see if they kind of, so they'll sort of just, come together rather than sort of running away too much. Yeah, that looks nice. Yeah, that's pretty much it. This is a pretty simple effect. Okay, so now the only thing left is to bring in the torchlight. Okay, because it's sort of like a fake thing. So let's just merge these two together. So we'll merge the bullet solver and the wall. And then take a light. So pick up a light here. I'll move it like back and up and change this to spotlight, and I'll spin it around to there. And what we want is we want to take a look at. So I wanted to look at this null. Okay, so take the light, come to transform, and it has something called enable constraint. So turn on enable constraint and click on this plus and you'll have look at. So click look at and then it will say select any look at object. So I'll pick that, press enter. It will say do you have a look up object? Like we don't. So press enter again. And yeah, if you press play, see. So what should happen is if we bring it back, now the problem is that the cone is too big. So come back to the light and spotlight and just make the cone small enough till it's about the size of this. Yeah, and we can just sort of up the intensity a fair bit. Okay, and so if you press play, see, there you go. That's what you get. So it's a nice effect that you get overall. And we can just for fun, I'll put in like an environment light as well. So it just lights up everything else, but really low overall, and make it like, I don't know. Yeah, so that's pretty much it. So this is how you can do particles reacting to light. It's a cheat, we're not really reacting to light, but it's just, you can give a similar looking effect. Now we have one final chapter left. So in that one, we are going to cover how to use audio to affect particles. Okay, so that will be the final thing we'll look at.